So cosec x, that's a reciprocal function. Which one is it? 1 over sine. Okay, so even if you don't know what cosec x looks like, it's not that hard to work out because we know what sine looks like. Okay, so let's just draw
sine x on it.
Yeah, so I mean, this is, I'll show you my piece of paper in a second, but I'll go through the process first and then I'll show you. Sine x, I'm going to put that in a different color, so it looks something like this. Okay, and the handy thing about it is that we know that its range is -1 to 1, right? So when you're taking the reciprocal, what's going to happen? Well, you're going to get things like 1 over 1, right? 1 over -1, which is also -1. Now what happens in between here? Right? Since I'm taking the reciprocal, every time sine x is 0, you get a vertical asymptote, yeah? I hope you guys have a really good graph. I should put my labels on all my vertical asymptotes, right? So there's 0, that's pi, and that's 2 pi. Okay, now what does the rest of it look like? I've only put 2 points on. Yeah, it's kind of like a parabola, isn't it? But it's not because it has these kinds of confines on them. Okay, so like so, and upside down over here. Okay, that's nice. Y equals cosec x. I suppose I should put that and that. Okay, happy? So yeah, that is what I do actually. Like this is what my sheet of paper looks like. So I just got my template out and I did my sine x, but I did it dotted so that it's not in the way of the actual graph because I don't have a green pen. So there you go. Okay. All right, where are we up to now? It starts to get really funky really fast. So this is the kind of question I was talking about before, right? Where they're going to ask you to integrate something in a second, namely that, but you're not expected to know what that is. Okay, so that's why they hold your hand through it. Okay. So, what's this? Is 6b? B? Is that right?
Yes.
Okay, I think they say show. Now I'm just trying to do it from memory here, so tell me if I get it wrong. Is that?
The derivative of the natural log.
Oh, sorry, yeah. I should differentiation there. Is that right? Yeah, okay, all right. Now, this is not that hard. This is just chain rule, right? So, walk me through it. Well, let's do the left-hand side. Okay. Wait, I'm not there yet. Now, it's a log, right? It's a log. So, chain rule with a log function should be f dash on f, right? F dash on f. And that's f in there, okay? So, what's f dash?
It's 1/2 sec squared x on 2.
Yeah, good.
Ish.
Okay? Chain rule of chain rule, so there's the inside of the inside, okay? And tan just turns into sec squared, no problems, okay? There's f dash, and then I'll stick f on the bottom. Now, I could write as a fraction, but because I'm going to get, like, I know where I'm headed, right? So I know this ought to simplify out nicely, and I want to avoid fractions on fractions, right? So I'm going to write that here. I know it doesn't make that much of a difference, but it'll just be a little neater, okay? Okay, sec squared, also a reciprocal, right? So which one is it? Cos. So that 2's down the bottom as well. So that's that term, okay? Now this division, this is sine on cos. So division, let's turn upside down. So cos on sine. And you can see what's happening, right? Cos cancels with this, and I'm going to have double of half angle on the bottom. Yeah? Can you see it? Okay, so we need to be able to recognize these kinds of things. We've been dealing with Trig expansions for a while, okay? So that's just sine x. Okay, done and dusted, all right? Now, therefore, what am I asked to do with this? Where did I take it?
Evaluate.
Oh, I need this. I can't
the definite integral of 1 on sine x.
Where's the, what are the boundaries?
Between pi on 2, from pi on 2 to pi on 3.
That's right.
Of 1 sine x.
Okay, so this is the classic setup, right? So they've showed us this weird derivative, okay, which we're going to use in the next part. This is just, sorry, let me get my bounds in place again. That's just cosec, right? with respect to x. So they're just trying to mess with you, okay, just to write it in a hard way, right? but I know what it's going to end up as. I know what the primitive function is because I just worked it out. Okay. So that's going to be equal to log of and that. Yeah?
We need to write brackets.
You mean these square brackets?
No, the brackets of.
Oh, you mean here? Those ones?
Is this not? It's one of those things.
Yeah, I probably should have. Though, what else would it mean? Like log of. Yeah, anyway, okay. So now I can evaluate at my upper and lower bounds, right? What am I going to get?
Log root 3.
Okay, so tan of pi on 3, tan 60 is root 3, right? And then now, even though what you're going to get will evaluate to 0, right? You shouldn't skip it because it's actually you're doing the evaluation at the lower bound, right? So that's tan of pi on 4, which is log 1. That's 0. Okay. And in the same breath, I'm going to take that index out the front because that's kind of a neater way to write it. Okay. So in case you missed that, that's 3 to the power of a half. So index laws.